Hi, I'm Curtis, and you're watching the third episode in my Nenina tutorial series. Now, while I will explicitly call out using Nenina with the Seestar, for those Seestar owners who've never used Nenina before, who want to learn how to control their Seestar and image with it using the powerful resources that we have in Nenina, pretty much everything I will discuss is relevant regardless of what telescope you use. Some of the settings, like autofocus settings, will be different with those telescopes and mounts than they are with the Seestar. Nonetheless, 90% of what I discuss in this series is completely one-to-one relevant no matter what scope and what mount and what camera you're using. In this, the third episode, I'm going to discuss 3 pages in Nenina. First is the Sky Atlas page, which allows us to find or sort through a series of potential targets we would like to look at. Second is the framing page, which allows us to adjust the way we image objects in the deep sky. Here we can do mosaics, and unlike the Seestar, we can do more than 2-panel mosaics. But realize, because Nenina is not a live stacking software, if you do a mosaic using Nenina, you're going to have to combine the mosaic images in post-processing software like PixInsight or other astrophotography software. And third, we're going to go through the imaging page. We're going to show the features that you'll want to have on the imaging page, how to get them there, how to move them around, and then we'll do some actual imaging. We're also going to do some plate solving as well. As always with my videos, I ask if you learn something useful to please like the video, hit that like button. The Google algorithm will recommend this video to more people. You may also want to subscribe so that you can be alerted when I post the remaining episodes in this tutorial series, as well as other videos. And lastly, if you would like to help support my channel at no extra cost to you, you might want to use my affiliate links to my 2 favorite astronomy retailers, as well as to Amazon, which I'll put down below the video where it says more. Tap on that and you'll see the links below. So let's get started. In addition to having Nenina running on your computer, you also have to download one additional piece of software, and that software is a plate solving engine, or software that's designed to do the plate solving for us. The recommended one from Nenina, and in my experience the best one to use, is called ASTAP, A-S-T-A-P. You can find ASTAP here at this address. It stands for Astrometric Stacking Program. It not only does plate solving, it stacks, it does a few other things, but we need it for the ability to do plate solutions. Nenina itself cannot do plate solving, but it will work seamlessly with ASTAP in the background to obtain the plate solutions and find and center the objects of interest. So you will need to download a copy of that, pick which operating system you have here. And then you're going to also need to have a database of stars. The program is great, but if you don't have any stars in that database, it doesn't know how to compare what it sees in the image and solve for its position in the night sky. So there are several different databases here. If we look down below, I'll tell you have to install the program and one of the star databases, and they show you the different databases here, the field of view that they're best over, and also the number of stars. So as you go down here, the database gets larger because it has more stars. That helps. Now, which database should you use? I think any of these down here will work. It also points out that if your field of view is 0.6 degrees or larger, you can download any of these. The field of view of the Seestar is 0.73 by 1.29. So it fits that criteria. So if space is no problem to you, just download D80. So you'll put your program under your program files on your hard drive, and then you'll put the database in the same directory as well. Let's go back. So let's take a look at this. So the plate solver here is ASTAP. You can use other plate solvers. I've used All Sky Plate Solver. It's good, not as good as ASTAP. I've used the SkyX Image Link. It's very good as well. But again, ASTAP is probably regarded as the best out there, and it is what Nenina recommends. Now, the blind plate solver, you could use a different one, but we're going to also use ASTAP. And blind solver means if it has no idea where it's pointing, it just kind of blindly looks and gets an idea of where it is and then zeroes in on the target position. And we'll keep this on. Now let's take a look at the settings for the plate solver. I think the default is 2 seconds for the exposure. That works okay. You could select to always use the UV-IR filter, which will give you more stars than the light pollution filter. I have it set on current, which means it'll use whatever filter is currently in position. Let's see how that works. We don't want to bin, so leave it at 1 by 1. We don't have a rotator, so this kind of is moot. Number of attempts, you could just make it 1. I have it set to 2 in a 1-minute delay, just in case some clouds roll over. I'd like it to try again. Now, the pointing tolerance. The bigger the tolerance is, the more off it could be from centering the object. The tighter it is, it could have some difficulty achieving that. The way to look at this is how many pixels is that. So the Seestar has a image resolution of 2.39, called 2.4 arc seconds per pixel. And 1 arc minute is 60 seconds. So divide that by 2.4 and you get 25. So what that means is the pointing tolerance is 25 pixels off in the X direction, 25 pixels off in the Y direction. It'll consider it a success. Now, is that good? If we go over here to the equipment page under camera, we see that we have 1,080 pixels in the x-axis and 1920 in the y-axis. So 25 out of 1,000 is 2.5%. So 2.5% of the field of view in the x direction. It's about 1.5% in the y-axis. I think that's tight enough of a tolerance, but that's something you could play with. Again, you make it too large, you won't get the object center. You get it too tight, and it'll just give up. So let's go back to the plate solver. So you can start with these settings. You can adjust them if you like, but those seem to work for me. And down here, we select ASTAP since that's what we're using. You can see where it's located here. Leave these at the default. The search radius means that if it has no idea, the search radius means it will go out as far as 30 degrees from the position the scope is pointing at, but no further than 30 degrees from that position. And that's pretty big. So that seems to work okay for me. Download the plate solver if you don't already have it, along with the STAR database, and you're good to go for plate solving. And we'll do a demo of that a little later in the evening when it gets dark. So let's go to the Sky Atlas. So the Sky Atlas enables us to find an object, to find information about an object, and then to tell the telescope to slew to that object. So let's go over this page. So I've typed in here M31, and it brought up this information here. So it gives you the names and all the different variations of the names of the object. Common names, NGC, Messier number, whatever, ARP number, gives you the right ascension and declination. There you go. This tells us the angular separation between the moon and the target is 79 degrees. This tells us its magnitude. This one tells us its surface brightness. This tells us its long axis is 3.15 degrees. Tells us it's a galaxy type and it's in the Andromeda galaxy. And then you're used to seeing this in the Seestar if you use Seestar. So here's time on this axis and here's altitude on this axis. We're at this point in time, 3 o'clock in the afternoon. And then you see this thing will transit just before midnight. It'll hit an altitude of 86 degrees, and you can kind of plan out when you're going to go look at this. You can also see shades of gray, and this is nautical night, and this is astronomical twilight, and then this is 100% dark. We can search for many different objects. So let's search for, let's say, M20, type that in there, and this will tell us about M20, which obviously it's in Sagittarius, I believe. Yep, there you go. It's low in the sky, and it's not visible at night. So you get all the same information for that. So the Sky Atlas gives us all this information about this particular object. But what if we wanted to look at a group of objects? For instance, we want to find out, well, what interesting galaxies could I look at tonight? So let's first clear this out. And then we could pick which day we're going to look at it. So we're going to keep it for tonight, but you could pick some night in the future. Then you can specify an altitude. So I want to say anything 30 degrees or higher. And once you select that, it allows you to pick the time. So we want to say, when do you want to start? You want to start at sunset, nautical dusk, or let's start at astronomical dusk. And then how long do you want to be able to see the object? So I want an object that's going to be up there and visible for at least 4 hours. Now we can also specify its apparent size. So something from, say, 30, let's say 1 arc minute up to 5 degrees. We can specify its distance from the moon in degrees. We'll leave that alone. We could specify the object type. So let's say we want to look at galaxies. I mean, you could do planetary nebula, open clusters, bright nebula, and so forth. You see all the choices here. We could pick the constellation if we wanted to. We could pick the coordinates. We could pick surface brightness, could specify magnitude, all of those things. We can order it by size, magnitude, object type, whatever. You can select more than one type as well, and how many items per page. So let's go ahead and say search. It goes off. It'll come back with a list. And so it came back with, starting with the largest first, which is M31, no surprise, the Andromeda Galaxy, M33, M81, Caldwell 7, and the list goes down, 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 down. If I scroll on the right-hand side. But also look here, there are actually 31 pages. Look down below. There's 31 pages of these things. There's 1,512 choices. So there's quite a bit here. You could narrow that down by being more specific in terms of the size or the number of hours or the time. We can do one more thing here. We can try Bright Nebula, and let's go search there. And there's the Witch Head Nebula. There's the California Nebula. There's the North American Nebula. And there's a bunch of other ones, sharpless objects, SH2 as well. So if you want to find out what's up there, what you might potentially look at, you can use this Sky Atlas to sort through and find objects. And then in the lower left-hand corner, what you see here is the illumination of the moon, moonrise, moonset, sunset, astronomical dusk, etc. So let's go clear this out. Let's clear these as well. And close that. Clear this. And then let's go back to an object like, let's say, M31. And there's the Andromeda Galaxy again. So from the Sky Atlas, we can pick and choose our object, and then we can do a number of things. We could actually slew right to it now and then go and try to image it. Or we could set it for framing assistant, which we're going to do, or add it to the target, or add the target to the sequence, which we'll do in another episode. So right now, let's set for framing assistant. That'll take us to the framing page. And so now you see a picture of M31. Now, where did the picture come from? So up here in the left, top left, you see the imaging source is HIPS 2 Fit Sky Survey. This is an online one, so I have to be connected to the internet for that. If I wasn't connected to the internet, I would have to use the offline sky map, or maybe I have some files that I took images of. I could use those as well. So there's a number of different surveys. These all require you to be online. These are things that have been captured and stored on your hard drive of your computer that you're working on. So I'm going to stick with this for now and explain this page using that. So first of all, it tells you the object that you're looking at, its coordinates as well. Now the field of view here is 6 degrees. That's a little bit big. We could drop that down here, and then we would reload the image. And you see here, it's telling you it's loading the image. There it is now. Now, it also has the camera parameters, so it tells us the width and height of the camera, the pixel size, and the focal length. And before I get into panels to do the mosaic, over here we can do zoom in again, zoom out. Can fit this to the page. It's already fit to the page. This is to make the scale 1:1. There you go, 1:1. Fit to the page, or 1:1. So it just fills the screen, or it fits in there the whole image. You see the outline of the image on the page. Now you can change the opacity of this image window. That's good enough for me. This will enable the sky background to rotate instead of the image. We're not doing any rotation because we don't have a rotator on the camera in the Seestar. This will allow us to display constellation boundaries. You're not going to see them here because this is all within the Andromeda Galaxy. This allows us to display and annotate the coordinate, the names of the constellations. Again, you can't see that here. Here are the display grids. Turn that off, turn it back on. This will give you the names of the objects. Sometimes this can get very busy. This one here I'm not going to get into. And down at the bottom it shows you the right ascension and declination. So there's the image. So suppose we want to, I just click and drag. I can move the image around. Maybe I want that. Maybe I want it centered here. So that's one level of framing. Next is, if we had a rotator, we could rotate this thing. We don't have a rotator, so we cannot rotate. Seestar doesn't have a rotator, but we can do a number of panels. So let's say we want to do 2 panels. There's 2 panels. Let's say we want to do 2 vertical panels. So we can capture pretty much the whole thing in 4 panels. And maybe we want to add 2 more to capture even more. So that would be 6 panels in total. So Nina would direct the Seestar to image this panel, and then this one, this one, this one, this one, and this one. And you see some overlap. So if I go down here, it tells us the panels, where they are, and then we can determine the panel overlap. Here is 20%. So you could make this 10%, 15%, or 10%. Default is 20. But again, Nina is not going to put these panels together for us. All it's going to do is take single frame images of panel number 1 until you're done taking the number of images we asked it to. Then it'll go panel number 2, 3, 4, 5, 6. You may have to do this over multiple nights. that's fine. You're going to put all this together in something like PixInsight or Cyril or other astrophotography software. So the advantage here over Seestar is you can do more panels and get a bigger field of view. The disadvantage is it's not doing it live and stacking them together, but that's not why we're using Nenina. If we wanted to do that, we would just stay in the Seestar app. So that's the advantage of using Nenina if we want to do traditional astrophotography with our Seestar. And then if you are connected to your camera, you can figure out what the orientation of the camera is, but that's not going to make a big difference to us because we can't change the orientation of the camera. We can only change the direction the optics points in. So now that we have framed it, I'm going to get rid of these panels. Let's just have one panel here. And actually, let's go back. Let's go back to the Sky Atlas and let's pick a different object, M30, M27. And then let's go to the framing assistant. And you see over here, it's pulling up an image off the FITS Sky Survey. There it is. And so you see how small it is in that field of view, but that's what it is. So again, we could move this around however we like. And then again, you have the information of the path through the night sky of the object here. So in this case, we can put boundaries. This is a boundaries. This is labeling some stuff. There's some more labels. So you can see some different NGC objects, LDN objects, and so forth. NGC 6873s down here. You can blow this up, fit it to the maximum. There we go, 1:1. You can see this in up close and see what it looks like up close, or we can go back. So the next thing we would do if we want to image this object is we would hit slew in center, and I'll do that a little later when it gets dark. So we'll do that tutorial. Let me summarize. On the Sky Atlas page, you can look for a single object. Just type in the name of the object up here. Let's put M33 in there. You see that? Now, just for grins, what if I put Dumbbell Nebula? Will it find it? No. And that's because it doesn't have a bunch of the common names. This one it did find. So sometimes it works, sometimes it won't. Sometimes it doesn't have the common names. So that's one little disadvantage. Those aren't all built in. Some are, some aren't. But we can use the Sky Atlas to find a single object, like the Dumbbell Nebula. We can then just go slew to it, or set it for framing, or add it to our sequence. If we do the framing, if we add it to framing, we'll come to this page. We'll see a little more details about it. We can set it up how we like it. But again, because we don't have a rotator on the Seestar camera, we cannot rotate this and change the angle to whatever we like. So the way the Seestar is doing that, it's doing actually a mosaic of many images to try to get it so it looks like it's rotated. And then it's cropping it. So let's go over next to the imaging page, which is here. Next is the imaging page. And before we go and do any actual imaging, plate solving, whatever, I just want to go through this page because this page actually was the toughest one for me to get comfortable with. There's a lot of things that you can put on this page, or a lot of things you can hide and not have on the page. I want to give you some sense of how to organize things here. What are the things that are available and how you can put them on there. So you can match what I have here or do what works for you. Think of the imaging page as central control. From this page, we can monitor what's going on with all of the equipment we're connected to. We can send command to those equipment as well. So when you set up a imaging session with Nenina, this is the main page you will work from. If you're going to do a short imaging session, you might sit here and monitor everything on the imaging page throughout the duration of your session. If you're going to set up and run overnight and go to bed while your equipment automatically runs, you would use this page to get everything started and to make sure everything is working as it's supposed to. And when you're satisfied everything's running as it should, you can let Nenina continue to manage things automatically, head off to bed, come back the next morning, examine the results of your run, and look at things like the statistics, the half flux radius throughout the night, see how well the imaging session turned out after all. At the top, we see all these icons here, and we should be familiar with these from everything we've done so far. So here's the image icon, camera, filter wheel, focuser. We don't have a rotator. There's the mount. There's no guider. This is for sequencing. This is a switch. There is none. That's a weather station, dome. Statistics, we'll find that useful. This is half flux radius history. We might be interested in that. No flat panel, no safety monitor. And this might be useful to us later, and so forth. And then over here are some tools. This is the 3-point polar alignment, which I'll get to probably in the next episode. And this is what's called a plugin, and the plugins are down here in the lower left. And then there's this aberration inspector that basically enables you to look at issues with your image. That comes with the Hocus Focus plugin, which I'll get to later. Star detection options, annotating stars, manual focus, autofocus, plate solving, image history, and imaging. So most of those things are down here. So here's the focuser right here. And I have the focuser set up here along with the camera. So they both share this same position. So right here's the focuser is selected now. I can select the camera. That'll tell us information about the camera. So the focuser tells us whether it's moving or settling in, what a current position. So the focuser is at 1576, which is where I last left it the other night. Tells us the camera temperature. So it's a reasonably warm day here. Then we can expand this because I can't read everything there. Temperature, compensation, on or off. We're not using that. I want to close this down a little bit here. I want to leave a lot of room for this block right here. This is where the image is going to be. So we can move the focuser. We can move it in whichever direction we want. We could select the camera, and this is going to tell us the camera gain and the temperature of the camera. Down here, I have two listed as well. I have the filter wheel, which shows up here, and this is where we could select whether we want to do dark frames or we want the light pollution filter. We would select whichever one we want. We would hit change, and then Seestar sitting over there because I'm connected to it and I heard it change. Then we can put it back to the IR. Then I heard it move again. Or the mount. And this is telling us what's going on with the mount. The mount is not tracking right now. In fact, I don't have the arm open. It's telling us all the information about time, position, altitude, azimuth, and so forth. None of this is very meaningful because it's just sitting there with the arm closed. This is the image section. The image will show up in here. When we get an image, I'll run through these things as well. Here's what's the half flux radius. This will give us a history as we take one image after the other, because remember, the objective here is to take many, many, many images and then post-process them later. So you can watch how the half flux radius is changing. Is it getting better? Is it getting worse? And then if you have the autofocus set up to focus every once in a while, it'll give an icon here, this little triangle, and tell you, oh, it did an autofocus at this point in time. And so I just have this by itself, and down below is the imaging pane that doesn't have the image, but it has the exposure time. So I can change that here, which filter, I can change it here, the binning, the gain, whether it's going to loop and continue to take images or just take one. So loop on means take an image, you'll see it on the screen of 30 seconds, then take another one, take another one, take another one, and refresh. So we're getting live views here of the images. And whether we want to save it or not, I have it save on, and you can put a name in here. Right now it just says snapshot. And the subsampling, I don't know what that is, and then we would hit this button to take an exposure. And we'll do that tonight. So this is a way to just take a snapshot or a single exposure. This is not the way to take a large sequence of images. And if you watch the second video, I showed you the autofocus routine. And if you remember from that, this curve looked a little less sharp. And that's because I went back to options, autofocus, and I adjusted the step size down from 15 to 10. And that has given me a bit sharper of a focus curve, which means we get a little bit better fit. So that's a good thing. Now, what's interesting here is I have autofocus shown up, but this section here also has the plate solving. And so there's the information of plate solving. Just click on that and it brings this up. And this would be the button to hit to start capturing an image and do plate solving, which we can only do when it's nighttime. I can change the settings here, the error, the settings I showed you before, the error, the exposure time, and so forth. And then there's the 3-point polar alignment routine, which we'll get into later. But the point I'm trying to make here is each one of these sections can be one or more things. So this little block up here is just the half flux radius. This is just the imaging. This shares among 3. This shares 2. This shares 2. You arrange it however works for you. Now, what if I wanted another one of these? Maybe I want the sequencer, because when we start doing sequences, we'll want to see this. We might like to be on this page and see the status of the sequencer. So I just clicked on it, and it put the sequencer down here. So there was room. It found space for it. It put it here. Now, if I don't want it, I can take it away. There's nothing to see in there right now, but once we get into doing sequences, it'll show where you are in the sequence as the evening rolls on. So that's pretty useful as well. Get rid of that. Now, I personally like to arrange it so the half flux radius is in the same block as the imaging is. So grab it, go to the center of this cross, then you see half flux radius and imaging are in the same place. We can also put the statistics down here as well. That one is down here automatically. And then I have the statistics, I have the half flux radius, and I have the image. We can just move the image over there. And then I like to put the sequencer over, let me grab the sequencer. And the sequencer, I like to put, here's the sequencer, I like to put it down below the imaging control panel. So I have imaging, I have the sequencer here, I have the actual image, I have the half flux radius history. I can watch this early on in the session, make sure everything's going smoothly, can check the statistics, easier to read on the big panel here. You should arrange this page for whichever way works for you. So for me, the working session is here in this big block, and then the commands and controls for individual pieces are over here. Might be actually nice to put the sequencer down here, since you'll see there's a lot of stuff on the sequencer be easier to read over here. Maybe I'll do that in the future. So it's nighttime. I have the Seestar set up outside. I just polar aligned it, and now I'm going to connect Nenina to it. So let's scan. There's the alpaca address. Connect the camera. Same with the filter wheel. The focuser. And then the mount. So before we do anything in particular, let me point something out here. On the camera page, the camera, Seestar camera, is reporting to Nenina that it's an RGGB bare color matrix. The reality is most people report that does not give the correct colors. And what people have found that seems to give the most reasonable color is a GRBG bare pattern. So you can just use this pull down here and do that one. I found mixed results. That seems to work reasonable so long as the exposures are 30 seconds or less and you don't raise the gain higher than say 80 or 100. So there's still something going on there that I think most of us don't quite understand, but it is what it is. All right, so let's go to the imaging page. We went over this layout earlier. Let's do a focus run. I just focused with the Seestar focuser not 10 minutes ago, and it came out at 599. And so let's make sure which filter we have in there. Let's go over here to the filter wheel, and you can see over here on the left hand side it's the IR filter. So that's what we want. And let's start a focus run, and as I mentioned before, I changed the step size, made it a little shorter, and I got a little bit steeper curve. So let's do the autofocus. And I will run through this. I'll speed up, and you won't have to watch this in real time. So Nenina is done. The focus position is 1601. The R squared of the curve fit is 0.97. So you see it's very, very close to what the Seestar got at 1599. So 2 clicks on the focuser setting. So that's a pretty good agreement between the two. Now if you are unfamiliar with the autofocus routine, you might want to go back and watch the second video in this series I produced on the autofocuser. I don't want to repeat all that here. I'll put a link to that down below this video. You can go watch that. So all we're doing tonight here are simple snapshots, single images, but we're going to use the Sky Atlas and the framing page as well. When we get to the sequencer, there will be a lot of action here because you'll be taking image one after another. We'll be getting data to populate this curve here, the half flux radius over time. If we set it up to refocus, you'll see when it does a refocus, it'll put a little triangle mark over here. We can expand this to make this a little wider. But right now, we're just doing single images at a time. And I went through these over here. So this is a one-to-one, fills the screen. This is to fit the image in here. One-to-one is 100%, and fit the screen is at 34%. This one rotates the image by 90 degrees, if you wanted to do that. This one will flip the image horizontally. This one will break up the image. This one is the aberration inspector, which I'm not going to go into because that's part of a plugin. That's part of the Hocus Pocus plugin. This will do a plate solve of the current image, and maybe we can do that here in a second. This puts the crosshair on. This one here is the toggles the auto stretch on and off. So if you don't stretch the image, it's going to look like that. So yeah, this one here, I'm not really sure of. I haven't really used this one. It says it toggles automatic star detection and analysis, the half-flux radius on off. Maybe we'll see that as we go forward. And then this is analyzing a Bahtinov mask. So if you're using a Bahtinov mask to focus, then you would use this to see, to help you determine when you have the best focus. So let's go back to the Sky Atlas and just see how this would work if we want to start imaging something. So let's pick a bright target, M31. Whoop. 31. You know how this works. So let's set for framing assistant. Here we are to the framing page. It's downloading the image from the Sky Survey. There's the image. We could move this thing around, but let's just keep it centered there. And then we're not doing a mosaic or anything. So we could tell it to slew in center, and rotate. We don't have a rotator, that just gives us an error. So we just hit the slew in center. So now here's the plate solving routine. So it's taking an image. If we go over here to the imaging tab, you can see down here in the lower left hand corner that it's slewed. It's taking an image, and here's this plate solving graphic. There's the image, it's solving the image, and now here's the data on the image. So the error, it's off by 3 in right ascension and 51, and it's not inside the tolerance. So it's going to expose again after moving. You can see, again, it's still not in the tolerance. Exposing again, solving, and I think it's happy with its centering. So we can close this, and then we can put the crosshairs on. So it centered the core. That doesn't necessarily mean it centers the core of the galaxy, but it centered it on the coordinates. There it is. Okay, so we plate solved, we got it roughly centered, pretty close. And we can take other images here. We can try a, let's try a 10-second exposure, because the plate solution was a 2-second exposure. Okay, there's a 10-second exposure. We can actually loop. It will do a series of 10-second exposures. Just keep looping. Got a satellite going through there. So we can loop, it'll keep looping until we hit cancel. We turn off the loop. It's saving the image. Now, here's where it gets interesting. Let me increase the exposure time to 20 seconds. You can actually see some dust lane here and here. Now we've kind of blown out the core, and let me just raise this up to 30 seconds, and you'll see the strange thing that happens with the color of the image, at least in the preview. This is a stretched preview. Nina has taken the image and stretched it so we can see it. If it didn't stretch it, we wouldn't be able to see it. There'd be data there, but the data is so far to the left on the curve, the histogram, that we're not able to see much. We have to stretch it to actually bring out all the faint details. Now, you see what happened to the color? And that's a problem that happens sometimes when there's too much intensity, and then when it does the bare matrix stretching, it comes up with some really strange color. And I frankly don't know what's going on there, but the data is being saved. So let's go where the data is saved. So the actual data is okay. So, so here are the first images, right? And then here was the most recent one that had that weird color, and you see it doesn't have that weird color. So the actual images that you save are not going to have a color issue. And then if we open up the FITS header, you can see the exposure, 30 seconds, meaning the gain is 80, pixel size, temperature, and you see it's still reporting RGGB. And if we go back, let's go back and set this to RGGB. Go back to imaging. Let's go back to 20 seconds. And that looks okay at 20 seconds, just like the GRBG does. Let's go to 30 seconds. Yeah, now you see the strange color there. So you can go through all the bare matrices, and if you get to 30 seconds or more, they will all show you in this stretched image really strange colors. I don't really know what's going on here. The reality is, let's go back here. Here's the latest image. Where are we here? And the image looks fine. So if anybody understands what's going on, please in the comments, you can let us all know. Eventually, I think we'll figure this out. As I said, the Seestar reports RGGB. Most people report that they get good results with GRBG in terms of color. I'm not sure what exposures they were testing that at, but I can get good color rendition, let's say 25 seconds. The point of this video is not to suss out why the color stretch is giving us problems, but rather to see how the imaging page works. 20 seconds works fine. All right, let's take a look at another object. Go to the Sky Atlas. Let's go find M27. So we want to look at a nebula. Let's go to the Framing Assistant. It's running through, pulling the image in. There it is. And then we'll do the slew and center. We can go to the imaging page for this. So you see down below here the mount is slewing. The first shot is not inside the tolerance. Declination area is way off. It's off by over a degree. So the final one, right ascension error is, it says it's right on. Deck error is 3 arc seconds. I don't know that's exactly that, but it looks pretty dead center to me. All right, let's then put in the other, here we go, filter wheel. Let's put the light pollution filter in, have it change, and then let's refocus. So our focus was 1601. Let's refocus. Okay, now the focus is 1594, and if we look back, I gotta see what I'm doing here. Hold on a second, can I get in? Yeah, let's go back to the previous one. 1601, and it was 21.62 degrees, and one more, there it is, 17.38, so like 4.5 degrees. So, you know, some of that for sure is cooling down. So let's go ahead and do a 20-second exposure on this guy. Okay, and there you see we've got quite a bit more intensity of the image in a 20-second exposure. If we go to 30 seconds, that's actually not too bad. It seems to work okay with the light pollution filter at 30 seconds. Let's see if we start to run into trouble as we go to 40 seconds. Yeah, you see, 40 seconds is too long for the polar alignment I have here, but I don't see any problem with color rendition with the light pollution filter, and I have RGGB. All right, let's go back to 20 seconds. That's a pretty, not too bad. That's pretty sharp. A little bit of motion there, but not bad. So that concludes our look in this episode at the Sky Atlas, the framing page, and the imaging page. It'll get much more interesting when we start with a sequencer, which I will either do the sequencer next or the 3-point polar alignment. So let me know down in the comments which you would like to see next. And as I get time, I'll work on both of them. I think the big advantage of using Nenina is using the sequencer. It's a much more sophisticated capability than the plan mode in the Seestar app. I'm not knocking the plan mode. It was nice that they put that in there. It's very helpful, very useful, but they're not going to write the code that was written here for Nenina and have all the features in the sequencer. I mean, the sequencer basically has all of these options that you see on the right-hand side. So even if we take out the dome, we take out a flat device, we take out, if you take all of the things, remove all of the things on this list that the camera we don't have with the Seestar, you still have all of these other commands that you can use to build a very sophisticated plan to image one or multiple devices over the night. And so we'll get into that next time, or we will get into the 3-point polar alignment. Thank you for watching. I hope you learned something from this. Don't forget to like the video and subscribe. Until next time, I think she's done. Till next time, clear skies.